在全球传播MySQL的福音。威哥介绍MySQL有什么好的东西，然后一些重要的 use case 那这是我们在全球MySQL里面来说是非常重要的任务。那我现在就把时间交给 Frederick。Let's welcome Frederick.
So hi everybody. I hope you will listen carefully to Venkatesh because there is a lot of stuff that we are using in for InnoDB cluster. So now this one will be about InnoDB cluster. First, if you can translate, my only question to them is, who has heard about InnoDB cluster?
有人听过 InnoDB Plus 吗？在这之前有人听过？3万种。
So the goal of this product is to make MySQL HA very easy for everybody. Because we understood that this was not a very easy task, and that people needed to be DBAs, but also sysadmin to be able to achieve HA with MySQL. So first, some word about who I am. So my name is Frederick. You can call me a friend, it's easier. I'm acting MySQL for a long time. I'm a DevOps believer, and I'm living in Belgium, the country of people. So 100% of people really want to have this HA to the system. Before, people were okay with maintenance window by night. It's okay, I need to do a change or I have an issue. Let's do maintenance window during the night. This is, with the globalization, this is not what we want. I don't think Alibaba will be down for 4 hours by night. They will cry, right? So we don't want that. So our goal was to make it easy for everybody, right? And out, let's say, one product provide you one product. So this is our vision. So one single product to achieve HA for MySQL. So our goal was to make something very easy to use, extreme scale out with high performance and out of the box. So and this is let's say a summary of all our goals, but as my time is reduced, I won't go one by one. But one thing which is very important is that to put it easy and all together in one project. Yes.
The rest of the time all are Multiverse. So you can the rest of the time all Multiverse. So you can extend.
Okay, perfect. Oh, so we have a lot of time.
I know the other person that's sitting on the outside waiting our.
So the vision of MySQL for HA and for the new product and let's say to make our community, customers happy, we have a vision in 4 steps. The first step was to create a document store. We don't have a session about document store, but it is to have SQL, MySQL with SQL and no SQL in the same product. This is possible right now already. So if you're interested in that, just come to the booth, MySQL booth, and we can talk about that. I will be very happy and my colleagues too. Then the second step was to make MySQL HA. This is done. This is InnoDB cluster, which is GA 5.7. So we have done this. It is possible already. But the next step, so what are we working on for the future, is to have a read scale out. And after that, we want to have a write scale out of the box for MySQL. So you don't need to do anything in your application. You connect your application, you have defined some stuff, and it works. Nothing for you. So this is where MySQL is working on right now. So I will discuss now the architecture to achieve these goals. So the first one, the step 2, so this is what you can do now. This is possible right now. You download the packages and you can do that. Is the HA solution, so high availability. So what do we have? We have applications here. They have a router, MySQL router, and here it is the InnoDB cluster. And you manage all that with the shell. So this is already possible. One node crash, where you are writing data, another one will take the lead, and you will write data there. So all that automatically. The step 3 architecture, this is almost possible right now, but not automatically. So what you can do, you can add asynchronous slave to these masters. But right now, if this master crash, these slaves are outdated because they don't get any data anymore. and you manually need to point them to somewhere else. But in the future, so the replication will be able to do it automatically by themselves. So you don't have to take care of that anymore. An asynchronous slave, when the master crashes, it will ask the group, oh, give me another master. So we are working on that. So this is step 3. And the last step will be to have these steps with a read scale out, but multiple of them, and this one will be replica set for sharding. So your application will connect on the router, and the router will identify that your data, maybe it's here. And so you write, and email writes here. Or I need to read some data, router will say, oh, your data is here, and you will commit from here, and you get it there. All automatically. So this is where we want to go. So the session now is about the step 2, which was HA, and I will discuss with you how we achieve HA with InnoDB cluster. So InnoDB cluster is MySQL group application, MySQL shell, and MySQL router. All three together, it's InnoDB cluster, in fact. The heart of it, so the biggest component of this is group application, like Venkatesh explained to you. So what it is, I will go fast because you just have seen, but this is very important. It's a plugin for MySQL that is made by MySQL and that is packaged by MySQL. It's not a third library that you need to recompile and try to use. No, it's all out of the box with MySQL. So it's an implementation of a theory, it uses Paxos-based protocol. You can write on multiple groups, but you have seen that with Venkatesh. We can have conflict detection, you can do the recovery, which it's also very important, it's supported on all platforms. Where MySQL runs, where MySQL is supported, group application, and InnoDB cluster, it's also supported and runs. And you can mix them. So you can mix a node in Linux, another node will be in Mac OS X, and another node will be Windows if you want. You can do that. There is no restriction on that. So this is quite very important for people who don't want to put their eggs in the same bucket. So for you user, what does that mean? So you don't need to take care to do this failover, manual failover, or automatic failover by scripting or checking, because there is a lot of script outs on Linux, for example, to do that. We do it for you. Then you will have fault tolerance. So you could have a machine that crashes, your system will be still running. You can update everywhere, like Venkatesh explained it. It's safe for crash. So this is easy HA for MySQL, which is our goal, right? So if you are more interested in how it works, it's just a kind of magic. But it works. So, but if you are you interested to know a bit more or not? Yes, so in fact what happens? Because maybe you have heard about group application and they say, oh, group application is a synchronous application. That's not true. The transaction delivery is synchronous, but the rest of the operation are still asynchronous. And this is why this technique is called virtual synchronous. So I will try to explain you that. But so every change we do, we send to everybody synchronously. Then, when we know they got the data, all the rest, certification, applying the changes, has to be done. Each node, they will do it by themselves, without communication back. So much faster than in a real synchronous world. So maybe it's not yet easy to understand. I will show you how it works then. So what happens here? We have a cluster with 3 nodes. We are modifying data on one of the nodes, right? So what happens? So the client connects here, modifies the data. This is time. Okay? So we send the data to all the other nodes at the same time. This is synchronous. Then if we zoom that, we see that we send the data. Depending on the latency of the network, we have to wait for the answer, right? Because we want to proceed when we get the answer. One thing that makes us different than other solutions in this way of replicating the data is that as we are using Paxos, as soon as we have a majority of ACK, so that say we get it, and we can proceed. It's enough for us. We don't need that to wait that everybody gets it. majority of the nodes gets it, it's enough, we can continue. So we continue the process, but of course, the other one will act anyway. So as soon as majority act, we start another process which is called certification. I will just give you some words on certification just after. But everybody certifies as soon as they can. So there is no here barrier to say, oh, we will all certify at the same time. We don't know. They all certify on their own. This is why this is asynchronous operation. When certification pass, commit is finalized. So you mean here we return to the client, right? And then the other nodes will do certification and applying the change. So on the time, this might be a bit later. We have some rules to check not go too far with flow control and stuff like that, but it could happen. And this is why, by default, we use primary mode, meaning that we're going to write always here and read most of the time always here if you need to read your own writes. If you don't need to read your own writes, you can read everywhere. If you need to read your own writes, right now it's better to read on the same node because you are sure it's there. It's not delayed by 1 second or something like that. Because it could happen. Or you need to verify that. Monitor that. Browser can do that for you to be sure. So what is this certification? The certification is a process that needs to answer only one question. And that question is, will this write be possible to apply on this node? That's it. If they can do that, it succeeds. If they can't, then it fails. So what do we need to check? We need to check all the other transactions that are not yet applied, that we have in the queue. And if we have a conflict, it means that we are writing on multiple nodes. So if you use only one node to write data, you will never have such conflicts. But if you write on multiple nodes, you may have some conflict, like Venkatesh explained you earlier. So, and this is also why, by default, when you install InnoDB cluster, you have only one primary master, so only one node that accepts the writes, to avoid this issue, because depending on the workload or depending what you're doing, you may have a lot of this kind of issue. If you're updating always the same record everywhere, you will have conflicts, for example. So if you don't know your workload, it's better to use one primary. If you know your workload and you know that you are safe from conflicts, you can write everywhere. So every node does certification, it's deterministic on every node, give the same answer everywhere, but they don't communicate back the result to speed up. So when it works, it goes in the applying queue. When it fails, it drops the transaction. Okay? So and we need to serialize this change with the GTID, and it's the order is done by our communication layer. So single primary node, this is what you already covered this. You can see it now if it is enabled or not. So when it's on, it means you have only one of the nodes in your cluster that accept writes. If it's off, all of the nodes will accept the writes. So it's like a master slave, in fact, but with the way that if the primary crash, they will elect a new one. As Venkatesh said also, now in 802 we have this way that you can define to force the elections. And we have also more visibility in performance schema tables where that tell you what's the role. So it's much easier also to find what's the role and which version are the nodes running. So this is in 802. 5.7, you need to use the query we showed you before. So this was about group application. The second component of InnoDB cluster is a router. So router is a very light middleware that has the only purpose to route the queries. So the application connects to the router and the router checks, I need to send the data to the writer or to the reader, for example. It doesn't detect, it doesn't check any, let's say, any query detection, this is a write or this is a read. It's just by port. So your application needs to know, I'm doing a write or I'm doing a read, and the router will listen to two different ports, and depending where you connect, it will split the traffic or not. So now, one thing very nice with the router is that you don't need to configure it. You just bootstrap, so you connect to one of the nodes, and it will configure automatically himself with the data that it gets from the cluster. So this is quite very handy. But now the router will focus on the sharding development. So the step 3 and the step 4 I show you, this is where the router the developers are focusing. So if you need a lot of more powerful proxy or router, then with group application and the InnoDB cluster, we are also working with proxy SQL, which is not part of MySQL, and is just a third-party friend company that we work with. And it is the only other proxy that it's compatible with group application by default. But this one is very powerful and has mirroring, read-write splitting, and a lot of multiplexing and all that kind of stuff in it that our router doesn't have for the moment. The next and the last component is the shell. So the shell is what we're going to use to orchestrate everything. So this is also not only used for the cluster, but it will be used for document store. It's the new client that we will push in MySQL. And we're going to use the admin API of the shell to configure and to manage our cluster. You will see, Ivan, you will show that after, so it will be, you will play with that if you stay here. So the shell will provide interactive and bash operation, document or relational models, so you can do a CRUD operation on it, or SQL operation. It's all possible with the MySQL shell. You can have output in different formats. And it uses the MySQL standard, so what you are used to when you use MySQL client-based command, but also the X protocol. This is a new protocol that we are pushing, that you will have asynchronous queries and stuff like that in the X protocol for MySQL. It is already available now, you can already play it. So this is how the shell looks like. So I think it's quite sexy compared to the previous client, right? With nice color and stuff. So this is the new shell, the shell for the 8 or for MySQL 8. So don't forget, this is an HA solution. Why I ask this? Because people say, oh, you have 3 writers, so 3 nodes. If I had another one, or if I start writing on 2 nodes, I will double my capacity. This is not true. Remember, we do it as much as we can synchronously. So there is no, let's say, guarantee that it's synchronous, but we try to. So it means if your top capacity for one node is 100 write per second, if you say, oh, I will write on 2 nodes, so I will be able to do 200 writes per second. If one machine can do 100, it means the second machine that will receive the new 100 writes from the application has to do already the 100 that you do on the first one. So this one is already on this capacity. So this is why there is no need to write everywhere, because it is not a sharding solution, it's an HA solution. It's in case of your master crash, you have another one directly without changing anything, not finding the binary position and stuff like that. You don't need to play with that. So this is an HA solution. So this is how you configure it. It's very easy with the shell. This is JavaScript, as you can see. So you connect, you can check the configuration. You can even configure it yourself from the shell, the missing settings. Then you connect, you create a cluster. Then you do instance state, add instance, check instance state, add instance, and it works. So you will see this all in action yourself in the next session. So I hope yeah, you will find it as easy as I do. So thank you for listening. Like Venkatesh said, I have wiki.com, find a lot of information about this. But on my own blog, you will also find extra information related to group application and Multiverse. I'm done.
谢谢Fred 给我们做的分享。